For two triangles to be considered congruent, all 6 parts of one triangle have to match up with all 6 parts of the other triangle. And we call those parts that match up corresponding. For example, BC corresponds to FE, and that's the statement right here. AB corresponds to ED, and that's this statement. And then finally, AC corresponds to FD, and that's this statement. So those are the 3 sides, and then the 3 angles also match. Angle A corresponds to angle D, and they're congruent. Angle B corresponds to angle E, and they're congruent. And angle C corresponds to angle F. So once all 6 parts are matched up, we can say the triangles are congruent, and here's how we'd write it. We can write triangle ABC is congruent to, and then I have to match up the corresponding parts. A goes with D, B goes with E, and C goes with F. So I would write triangle DEF. And if I rearranged the letters here, I'd have to rearrange the letters there to preserve the correspondence. For example, if I wrote triangle BAC is congruent to, then I would have to write triangle EDF. We are going to spend a lot of time in the next few weeks trying to prove that triangles are congruent, and it would be quite tedious if we have to establish all 6 of these as being congruent before we could say that the triangles are congruent. And it turns out you don't have to use all 6 of these. There are packages of 3 that you can use to establish that the triangles are congruent, which saves a lot of time. There are 4 general ways to prove triangles congruent, and the first is SSS, side, side, side. And what this says is that if you know that all 3 sides of one triangle are congruent to all 3 sides of another triangle, then those triangles must be congruent, and their angles must match up. And this should make sense, because if you have 3 sticks of 3 different lengths and you put them together to form a triangle, there's no other triangle that you can make with them. A second method is SAS, and here if you know that 2 sides of one triangle and the angle between them are congruent to 2 sides of another triangle and the angle between them, then those 2 triangles have to be congruent by side, angle, side. And the A is between the S's because the angle is between the 2 sides that we're using. A third method to prove triangles congruent is angle, side, angle. And here you can see that one pair of angles matches, a second pair of angles matches, and then the side in between those pairs are also congruent. So by angle, side, angle, in other words the sides between the 2 angles, these 2 triangles must be congruent. And then finally there's angle, angle, side. And here, like before, we're going to use 2 angles, but the side is not between them. So here we have 2 angles and a side not between them matches 2 other angles and a side not between them. So by AAS, angle, angle, side, these triangles are congruent. You could also call this method SAA, and those are really the same thing, because in both cases the side is not between the 2 angles that you're using. Next, I want to take a moment just to digress and talk about the importance of SSS congruent triangles. Many of you have ridden bikes for years, and when you ride a bike you might notice that the frame is made up of triangles. The biggest triangle on a bike frame is this one. And by SSS, once those 3 sides are formed, that triangle is locked into one shape, and it's very, very strong. And you'll see many structures that hold weight are built of triangles and not of other types of shapes. And somebody who's very heavy can sit on that bike, and this triangle will hold its form. In fact, there's another triangle that sits behind it with the back wheel, and that triangle is also by SSS, very, very strong. Now, contrast that with something down below, like a square. And if you were building a bike out of a square, then when you put weight on the top of it, over time, that square will start to deform and form a rhombus. And it inherently is not nearly as strong as a triangle. So when you look around at construction sites, at bikes, at other sorts of objects that are meant to hold weight, you will see triangles everywhere. One collection of 3 parts that we have not used to prove triangles congruent are SSA. And by the way, SSA, the angle is not between the 2 sides. And of course you could write it this way as well. And if you notice these 2 triangles, you'll probably guess that they're not congruent because they look quite different. But notice that they have an S that matches, another S that matches, and an A that also matches. But the angle is not between the 2 sides. So it's possible to have ASS of one triangle match ASS of another triangle, but the triangles aren't congruent. The other collection of 3 letters that we didn't use are AAA, angle, angle, angle. And I'm hoping this picture conveys that just because 3 angles of one triangle are congruent to 3 angles of another triangle, the 2 triangles are not necessarily congruent. What they are, in this case, are similar. In addition to the 4 methods that we're going to use in this unit to prove triangles congruent, SSS, SAS, AAS, and ASA, there's a 5th method that works, but it's just for right triangles, and it's called hypotenuse leg. If the hypotenuse of one right triangle is congruent to the hypotenuse of another right triangle, and the leg of one is congruent to the leg of the other, then by HL, the triangles have to be congruent. And what you might notice is that this is an ASS situation, or an SSA situation, and right triangles are the one case where ASS works. And rather than calling it ASS, we call it HL, hypotenuse leg. Okay, let's now see if we can look at some pictures and decide, first of all, whether the triangles are congruent, and if so, by what method. And in this first picture, we have one triangle and a second triangle, and we see that there's an S established, this side matches this side, and we have an A established, this angle matches this angle. We also know that they share a side, so I'll mark that as one we can take advantage of too, because it must be equal for each of the 2 triangles. So now when we look at one triangle, we see that we're using 2 sides and an angle not between them. So that is 2 sides and an angle not between them. But we know that we can't use SSA. So it looks like these 2 triangles are not necessarily congruent. Let's now look at the second picture. We have 2 triangles, that one up above and that one down below. We've got one pair of angles that match, a second pair of angles that match, and we can also note that they share a side, so I'm going to mark that as something we'll use as well. And now if we look at either one of the triangles, we're using 2 angles and the side between those angles. So that sounds like ASA. And that works, so we can say that these 2 triangles are congruent. Alright, next we have 2 triangles, one on the left, one on the right, and they share a side, so I'm going to mark it. And then you can also see that the other sets of sides match. So by SSS, these 2 triangles are congruent. And in number 4, we have one set of angles, that's an A. We have one set of sides, that's an S. We can also take advantage of the vertical angles right here and here, and I'm going to double mark them to distinguish them from the single marks. And now, by ASA, these 2 triangles must be congruent. In number 5, we have an angle, and a side, but that's all we have, so there's not enough information here to say the triangles are congruent, so we'll have to indicate that they're not congruent, unless we learn more information. And then in our last picture, we have a side matching a side, we have an angle matching an angle, and we can also take advantage of the vertical pair here, so I'm going to mark this angle congruent to that angle. So now by ASA, these 2 triangles are congruent. Alright, let's do these final four. In this picture, it's a little bit tricky in number 7. We know that that side matches that side, this side matches this side, and then these angles match. But notice in this triangle, the angle is between the sides. In this picture, the angle is not between the sides. So these two triangles are not necessarily congruent. So I'll put not congruent. Okay? In number 8, I think that's pretty quick to see that those two triangles are congruent by SSS. And then in number 9, we've got one side matching another, a second side matching another, and let's take advantage of the vertical angles right there, and it looks like we have two sides now and the angle in between them that we're using. So that's side, angle, side, and those triangles are congruent. And then finally number 10, we'll take advantage of the fact that they share a side and mark that. And now we're using side, side, side. So by SSS, these triangles are congruent. Oh, I could put the congruent symbol over here too. And that's it. Okay, in this final set of problems, we're being asked what additional information is required to know that the triangles are congruent by the method given. So in number 11, we need to show that these triangles are congruent by ASA. Well, we know that these angles match. That's an A. We know they share a side, so that's an S. And then, if we can show that these two angles are congruent, then by ASA, these triangles are congruent. Alright, number 12, let's take advantage of the fact that they share a side. And now, in order to prove these triangles congruent by SAS, we need to find a side on the other side of the angle. So let's match up this side with that side. And then by SAS, these two triangles are congruent. Number 13, I think, is a quicker one. As long as these two sides are matched up, then by SAS, these two triangles are congruent. Number 14 is very similar. We have two angles that match up. In order to use ASA, we need the side in between them to match up. And then in number 15, in order to use SAS, we need to use the side on the other side of the included angle, or the marked angle. So we need to do that over here as well. And now by SAS, these two triangles are congruent. And then finally, ASA on the last problem, it looks like we'll have to make the side be between the angles we're going to use. So I think I would mark this angle being congruent to that angle. And that's it.